Welcome everyone to this second webinar in this series called Behind the Hype regarding AI innovation. So today it will be on cognitive AI. I will give the floor to Stefania De Santi as a coordinator of EIC Communities project to welcome you also and to give you a short overview.
Thank you very much, Hedi, and welcome everybody, dear ladies and gentlemen. I share my screen to give you a very brief overview of the EIC Communities project. Okay. So the EIC Communities project is a Horizon Europe project that is coordinated by APRE, the Italian Agency for the Promotion of European Research, and implemented together with three additional partners, ABN, the European Business Innovation Network, EURA, and ICONS. And the projects aim to support the European, the EIC projects to be valorized and to create networking and connection to go faster to the market and have more impact on the market. In order to reach the scope of the projects, three communities of practice have been created, one dedicated to clean tech, one to industry, including digital and space, and health. So several activities are organized mainly online, but some of them also on site in order to promote the interaction among the EIC portfolios. So within the projects has been developed the DeepSync platform. Here you see the website, deepsync.eu, in which all the projects financed by the European Innovation Council and the stakeholders that join the communities of practice are visible. Furthermore, you can find all the information about the initiatives that are organized within the project, including the Beyond Hype series of webinars. We have also social media channels, LinkedIn and Facebook. And you can reach us also by email to info@eicommunities.eu. We want to focus on the series of events Beyond the Hype and the next events. So in particular, after the today meeting, we are organizing a meeting on the 7th and on the 10th of April. They are in the context of the Future Tech Week, that is an online week-long initiatives. And here you see the agenda of the events. It's already open the registration. So you have here the preview of the link and the QR code to register. This is the event of the 7th of April. And here you have the event of the 10th of April. So we hope that many of you will join the events in April and stay tuned on the activities that we are going to propose and organize. So here I let the floor again to Hedi to introduce our speakers.
Thank you, Stefania. As you can see today, we have a very exciting agenda with distinguished speakers. So we'll start soon to give the floor for the first one, Sadek Sujani, which Sadek is a researcher, a group leader at Max Planck Institute for Software Systems in Germany. He has held prominent positions at Newcastle University and Oxford University, focusing on AI and safe autonomy. He has published over 150 research articles and secured over 8 million euros in research grants. He is participating to EIC Pathfinder SIMAWare project, and also his recipient of ERC Consolidator grant, and also he's recipient of EPSRC New Investigator Award. So Sadek, please, you have the floor. You can share your screen and Go ahead.
Yes, that's great. Thanks, Hedi, for the introduction. Let me share the screen. You see my screen now. Yeah, the slides is visible.
Perfect.
Great. Thanks everyone for joining this session and also for inviting me to give this presentation. I will provide a high-level description of cognitive multi-agent systems within the next 17 minutes. I will keep it very high level, but I'm happy to go into the details as needed. So in general, when we look at techniques under the umbrella of statistical AI, we are talking about techniques that are based on probability and finding patterns in data. Usually these techniques are data-driven to learn patterns from large data sets, and they handle prediction, optimization, pattern recognitions, and so on. And usually they need large data sets to learn. And often they are forming black box models, and they are hard to explain. It's difficult to understand how the mechanisms inside these black box models are working. But then when we look at the other side, we have cognitive AI, which is essentially inspired by human reasoning and cognition. They are knowledge-driven, based on using logic and reasoning. And they are expected to handle complex reasoning, adaptation, and providing explanations for the outcomes of these mechanisms. And they are expected to work with little or no data while providing explanations and being transparent. We also have the term hybrid AI, which essentially says that we don't need to restrict to one of these two sides. We should combine them. We should combine techniques from both sides. For example, from the left-hand side, we can take techniques from machine learning and deep learning. From the other side, we can take symbolic reasoning. And this will help us to create autonomous systems that can effectively reason, learn, and adapt more effectively. So what is the added value? The symbolic reasoning that I mentioned to provide explanation, justification, and adapting decisions. Another added value is ontology-based knowledge representation to share common understanding. Another aspect is to make the agents goal-driven in their behavior, for example, to prioritize and plan based on evolving situations. Another aspect is handling conflicting information. And finally, learning and adaptation to improve over time. So what is the question that we are asking on cognitive multi-agent systems? The question is how these cognitive capabilities will improve autonomous safe AI. And to answer this question, we need to develop an integrated environment for programming, verifying, and designing multi-agent systems that perceive and act in the uncertain physical world. So here I would like to emphasize the role of uncertainty. When you look at many of the application domain, think about, let's say, autonomous driving, or robotics, or energy networks. There is uncertainty in the network already. There is lack of information on how the other agents in the network behave, and we should make decisions under this lack of information. So it's important to address uncertainty that is the core feature of these systems. The other aspect is that we need to do programming. We are designing these agents, and we need a programming environments to develop software, implement algorithms, and efficiently implement decision-making mechanisms. What are the challenges of designing such systems? From the application point of view, these systems are large scale. There are lots of agents interacting with each other. Think about the traffic network. You have cars, pedestrian, bicycle, and so on. At an intersection, there is a complex scenario that everyone is making decisions. There is complex interactions between these agents in the network. And as I mentioned, we have uncertain environments. We have to make decisions on their uncertainty. When we look at the theoretical foundations of designing these systems, we have other set of challenges. One of them is the lack of precise models. We don't have precise characterizations of the behavior of these agents in the network. And these agents are changing continuously over time. Think about a car, driving a car. The speed of the car is changing continuously over time. And also we have complex requirements on the behavior of these agents. Also highlighting another aspect is the interaction of the software with the physical system. The physical system being an artificial agent or a human agent. The interaction between the software and the physical system creates behaviors that we usually that we don't often see in the software or the physical system separately. So these additional behaviors are the ones that we have to study and make sure that that these bad behaviors don't create unsafe scenarios when we design these systems. Now let's look at the complex requirements that I mentioned in the previous slides. For example, if you have a traffic network or a train network in the right-hand side, we have strict safety requirements. There should be no collision between the agents in the network. And these requirements, no collision requirements, we can write them using logical formulas. I mean, you don't need to understand what I have written in this slide, the right-hand side. These are just to show that we can capture them precisely in a way that everyone can understand them. The same thing with the speed limits. If there are speed limits in the network, we can write down logical formulas that capture these speed limit requirements on the traffic network. We have assumptions on the behavior of the components in the environment. If we have, let's say, traffic lights in an intersection, you want the traffic lights to behave in a way that the intersection becomes empty infinitely often to allow you to progress and move towards your destination. Again, we can capture them using logical formulas. We have also goals for the agents, another set of logical formulas that can describe these goals. Now let's look at how we can design an approach for addressing such systems. When we look at these rules, requirements, knowledge, and assumptions, we have the symbolic logic domain. Think about a bunch of symbolic states and jump between these states. When I look at the physical side, we have quantitative models. For example, think about the car. I can write a bunch of differential equations for capturing the behavior of the continuous variables. Think about the neural network that's already embedded in the autonomous car that works on the images taken from the environments and translates them into recognition of the traffic signs. So these are quantitative models that work with continuous variables. And then the question is how to bring these two domains, these two distinct domains together. So there are two approaches. One is to get everything into the symbolic domain. If I have a quantitative model, I can somehow represent it with another symbolic model using some approximation, some proper approximation. And then once everything is in the symbolic domain, I can try to design an efficient system using the appropriate techniques. That's one approach that we have been exploring. The other approach is to bring everything into the quantitative domain. If I have logical formulas, I might be able to design some quantitative semantics for these logical formulas, and then I can do optimization and design algorithms using these concepts from mathematics and other domains in the continuous domain. Now let's see how this could work and what is the role of data. In the corner, in the top left corner, you can see a real safety critical system. We can gather real data or data from the simulators of the system, and then we can build symbolic models using data directly. These symbolic models are somehow representing abstractions of reality, and they can help us to design symbolic decision-making mechanisms based on the high-level requirements. The other aspect is that we can directly design these decision-making mechanisms without going into the discrete domain using certificates for safety and other logical requirements on the system. So the question that we should ask here is how to build the correct representations of systems, of agents, And by the correct representation, I mean that we need some kind of certification that these representations are correct representations of reality, and they don't miss any behavior of the agents. Think about the car with some differential equations. I represent them with some symbolic model, and I want this symbolic model to over-approximate the behavior of the car with high confidence. This gives us some notion of trustworthiness of the design that we have for these cars. And there are some techniques that we have been working on in the past few years to have this kind of certification on building these abstract models. Another aspect is the efficiency of these symbolic models. When you have these symbolic models, you may need exponentially large memory to represent them. We have been exploring how to use neural networks as correct representations and compact representations of symbolic models. And for this, we need 100% correctness. And neural networks, we know, generally can make mistakes with some small percentages, and we can correct their behaviors by combining them with small lookup tables. And this is what we have been exploring to reduce the memory requirements for these symbolic models from gigabytes down to kilobytes. So another aspect that's important for these logical requirements is to how to perform learning without having a proper reward function. And we have worked on using these logical formulas to design reward machines for guiding the learning in the continuous domain and having, again, some certification on the correctness of the learning and their convergence to the optimal solution. And we have also shown that these techniques can be made compositional with respect to the structure of the network. If you have multiple agents, you can have local learning mechanisms for each one in order to collectively satisfy high-level requirements. Another aspect that I want to highlight in this slide is to inspire from the way our brain behaves when we cross a street. Imagine that you want to cross the street. You already have some model of the car approaching you in your brain, and you make your decisions based on that model. So you make some estimation of how fast the car is moving, and then you can decide whether it's safe to cross the street or not. So we naturally build these models in our brain and use them to make decisions. And we have shown that we can do the same thing when we design algorithms for artificial agents, that they can use data from the other agents to build some representations and use them in their decision-making mechanisms in conflicting scenarios. And again, all this is with respect to the safety and other logical requirements that we have on the system. So here I also highlight some certificates in the continuous domain that we have shown we can design to ensure safety. Here, the blue curve around the red car is a kind of certificate that if you don't cross that curve, you don't hit the red car. And that's a kind of certificate. If we can manage to compute them, we are sure that the system will remain safe on the actions taken by the other car who is trying to overtake. So we can use, for example, conditional embedding to build these certificates with appropriate confidence on their correctness. We can use neural networks or polynomial templates to get these certificates. Similar certificates can be constructed for reaching a destination. That's another requirement. We can have some kind of partitioning like onion layers on the space that the agent is moving. And then if we can show that with positive probability, we are going towards the reach set, then we will reach with probability 1. So there are some fundamental theoretical details that enable us to characterize these certificates. The other aspects that I would highlight here is to improve the efficiency and satisfaction using data. So we have imprecise knowledge about the behavior of the agents. By having additional data, we can build better abstractions of reality, and we can improve the confidence on the decisions we are making as part of as part of designing multi-agent systems. Just another aspects that I want to highlight is the activities that we are doing in the CMAWare project, which is funded by EIC in a Pathfinder challenge, and we are focusing on situational awareness in mixed autonomy. And the core of the techniques we are developing is how to have different notions of awareness and how to implement them algorithmically as part of the software tool embedded in these multi-agent systems in self-driving cars, for example, or in drones and so on. Another point I want to mention is that we are doing some startup activities as part of Azon AI to build a risk-aware gatekeeper for AI-driven autonomous systems. And we are looking for providing certification for these AI algorithms in different application domains, from warehouse robots to autonomous driving and healthcare. Finally, highlighting some samples of ongoing research. I believe that robustness is a key in trustworthiness of cognitive multi-agent systems, and we need to make sure that whatever we design is robust with respect to the assumptions we make on the behavior of different components and how they interact. The other aspects that we are working on is how to handle algorithmically aleatoric and epistemic uncertainty, and we are designing efficient algorithms for this. The other line of research that I'm following is implications of fairness in temporal logic verification, and to have more efficient designs with respect to the resources we have. And recently, we are pushing two other directions: resilience of cognitive multi-agent systems against disruptions, which I think is becoming more and more important, and handling communication between agents in a multi-agent system. With this, I would like to thank everyone and acknowledge the contributions of the students and postdoc. I'm happy to take any questions.
Thank you, Sadek, for this nice presentation. I see that there is already questions coming in the Q&A channel. So all attendees, you are invited to use the chat and the Q&A channel for asking questions for the speakers. So nice also to see this background of the presentation coming from let's say theoretical research in ARC scope and then the EIC also scope. So to show how we are pushing research from theory to innovation and to real applications. Great. So first question from Alex. How does your algorithm cater for the irrational human agents in traffic, maybe in a hurry and break the rules? So crossing by red lights and so on.
So I think this is related to the certificates we design for these systems with respect to the perception. So if you have irrational drivers in a traffic network, you have these safety certificates that if they come close to you, you have to shield yourself and reduce your speed or stop. So if we handle a real-time decision-making based on perception, I think this shouldn't be an issue. And again, this goes back to the parts that I mentioned related to assume guarantee contracts, that you make an assumption on the behavior of other agents, and then you make decisions. We need a hierarchy of techniques that you have these assume guarantee contracts at the lower level, and then you have some safety shields on top to override decisions if the assumptions doesn't hold.
Great. Is there any other question to Sadek, or we can move to the next presentation? And I think Sadek, you already made a bridge when you started to talk about startups, because next presentation will be by a startup funded by the EIC. And then for the questions at the end, we will have a session of a panel session. So also you can still ask questions later for the attendees. So let's move for the second presentation that will be done by Bartosz Pampusz, who is the CTO of Blinkin. He's also former Microsoft MVP, and he has over 20 years of experience with a big passion for innovation. So the floor is yours, please. Go
Yeah,
ahead.
thank you for this nice introduction. I have learned something about myself. Basically, yes. So I represent Blinkin, a startup, a EIC awardee startup, where I have the privilege of being a CTO. And basically today I would like to share with you our findings and learnings from our journey and cooperation with with our customers and users who we have decided to enhance with AI. So basically, we claim that we reshape how people interact with the real world through our multimodal AI. And what I mean by that, well, basically, I just hope that the slides are visible, right? My screen is visible and you can, all right, great.
Perfect.
So basically, we all know that AI is very common nowadays. We all have access to very powerful tools and really great solutions, sometimes deployed as services, sometimes being just the models that we can use. And we are not talking only about commercial paid systems. There is plenty of ready-to-use solutions. There's a great place called Hugging Face where everybody can find a machine learning model to help with some tasks. And currently, there's already over 1.5 million open source models that are available just for download, and anybody can take them. So it's basically, you have a specific task to do, you can find a model that can be the base for the problem that you have. And of course, if you don't know which model to use, there are other services like Papers with Code, for instance, where you can browse the state-of-the-art models and get the benchmarks to see which model performs best at the moment, which model is the state of the art at the moment for the specific task that you're looking for. So we have the tools, but when it comes to reality, well, people struggle. People struggle with basic, simple processes or problems that they face on a daily basis. So it's not like that everywhere we look at, we have an ML or AI that will solve the problem for us. And I'm going to give you an example of a process that is supposed to be deployed in the upcoming months or years, depending on the legislation, in Germany. So basically in Germany, people are supposed to upgrade their electricity meters in the upcoming years, and all of them will need to have so-called smart meters. As simple as it seems, well, it turns out that it is a very challenging problem. So it's not that people will look like this and wonder what to do. It's actually people will get mad, believe me, when it happens. And there are so many different types of meters. Some are smart, some are, I would say, ancient. Some have optical readers, some don't. So it's like a mess, a total mess on the market. So basically, the person needs to figure out, what model do I have? Is it even a digital meter or not? How do I turn this into a smart meter? Is it compatible for an upgrade or not? Do I need an adapter? Et cetera, et cetera. And they struggle. They have to call. They have to do a lot of things in the process. While what it should look like and what it looks like with help of our tools is, you just take a picture, you just take your phone, take a picture of your smart meter, and you are led by hand, like, okay, we can detect the vendor and model. We can do the whitelist check. Is it applicable for an upgrade or not? We can match the appropriate process for your particular device, guide you somehow through a limited actionable steps, not a large manual, but just the simplest, the most simple approach. And also do a lot of other things. This is what it should look like. And also, if you need a PIN, for instance, to access your meter, smart meter, well, you usually don't know how to even get it. So we let you take a picture of your invoice. We detect what grid operator you have. We find you the phone number, and within one click, you can just call the grid operator and get the required PIN. So it simplifies things within the process. So this is just an example, of course, of a process. We have plenty of others, like product registration, where all you need to do is scanning a plate. For instance, interactive product manuals, where you can talk to a chat, but it's all based on real manuals. We have product onboardings, where you can learn how to use the product, and other use cases as well. So basically, we believe that this should be reality, given what's possible today. And of course, everyone knows this. Everyone knows that every organization must become AI first. Everyone, a great presentation that we just heard 20 minutes ago about AI agents, right? This is a multi-trillion-dollar opportunity. Everyone should be there. So if it's that simple, why don't the companies do this? Why is it's not as popular as these tools that we have available as consumers? Well, it's because deploying AI in an organization is a completely different story. You have to be compliant with, you have to fit into the existing processes, utilize domain knowledge, be compliant and aligned with policies, do a lot of integrations and other things. And basically, in order to do this properly, you need data scientists to know what to do and how to do, and expose this kind of solution to their customers. And we are trying to change this. We are trying to bridge the gap between what's possible nowadays with AI with what companies do. And we do this through a set of solutions. Our platform, an ecosystem, combines our proprietary Blinken Agents platform, where you can build agents, put them into crews, and let them collaborate like real humans with different orchestration patterns. We have Blinken Studio, which is our no-code visual editor for AI-powered processes. We have our own vision language model to enhance agents with vision capabilities and also understanding, and a Blinken Hub, where you can instantly launch any application built through the platform. And just to give you some examples, some additional examples, not on slides, but in reality, I would like to show you what it looks like and how we can do things such as the aforementioned use cases, but also plenty of others. So basically, I'm going to switch to the system to show you the most fundamental things. So basically, when we define agents, we define these agents as using natural language. So we equip them with so-called tools. So for instance, I can say, okay, I want my agent to be able to perform internet search and also read web pages. And it's all I need to do to start interacting with this agent. But I can also program this agent by providing reasoning guidelines or asking it to prepare a plan before execution, etc. So I have a simple agent here, which is called Meeting Assistant, that is supposed to prepare me for a meeting with a company. And I added these two tools to the agent, and I said, I want you to get some research about the company, extract basic information, and read some other additional information. And that's all I need to do to start talking to a single agent. This is a very simple system, of course, right now. But I can say I'm having a meeting with Microsoft. And if I do this Meeting Assistant will try to figure out, based on the reasoning guidelines, what could be useful for my meeting. Of course, if I'm more verbose with my requests, I can get more information. And basically, it performed some internet searches in this particular case. It found some sites, and it got some results like here, right? So this is the way you build agents. But of course, for agents to be powerful enough, you need to enhance them with different modalities. We need to be able to put them into groups, as I said. So just to give you another maybe silly example, but something that will also show you how simple it is to build these things. So we have an agent called Image Analyzer. This Image Analyzer is equipped with our Blinken VLM for image understanding, and that's all it does, nothing more. I have an agent that is called Writer, that all it does is write generic texts or answers generic questions, and I ask it to make sure to ask for topic, text length, format, target audience, tonality, and these things to make sure that the article is good. And I also have image generator agent, for instance, that I can use. Let me just clone this agent for me to be able to use it here. And I have this image generator, which I will equip with image generation capability. And that's it. I will let the agent decide what to do. And having these agents, I can simply start a new conversation. For instance, with a writer, the aforementioned agent, right? Simply click OK, writer, and say, OK, I'm going to use writer. I'm going to use this image generator that I added, and maybe this image analyzer that we also had. And having these three agents, I can simply start a conversation. I need to write an article about computers or maybe about AI trends. And just by this crew is supervised. So my intentions were analyzed by the supervisor, who has like kind of scratchpad understanding what's going on here. And we can simply, it asks me further questions because this is how the agent was programmed. Do what you think fits best. And I can simply keep talking to this agent, and it will write the article for me. Then if I ask to generate an image, I can start, generate an image for a magazine to illustrate this article. If I do this kind of thing, I think I haven't cloned image analyzer. Sorry, so I don't have it. Basically, it should choose the image analyzer here and generate the image. But basically, the idea is to be able to structure the entire conversation and keep going. This is one of the. Oh no, it actually did its job. Sorry, it actually did its job. So I have this image, and I can ask, is there anything that could be improved with this image? And if I ask this kind of thing, it selected the right agent. I haven't noticed that. It selected image generator here, and here it selected image analyzer for the next task. So now it's talking to our vision language model to understand this image and propose what could be improved, right? And we have this set of lists which I can follow up with okay, do it to get a new image which is based on these findings. So this is one of the examples. But to give you one more example, I have created last week during our event an app that was called From Video with Business Cards to 1 minute pitch. So it was like I shot a video with business cards, just a few business cards being replaced on the table, and this was an app that allowed me to, first of all, extract the information from the video using our vision language model, so understanding what's in the video. Then it got to the to an internet search, so it found the information about the companies represented by the people who I met at the conference, and then I asked it to give me some information about how to approach the second company. And based on the understanding of my company, I got a one minute pitch to fully automated how to approach this company. And it was all possible because I had another agent who had access to a space where I uploaded my slides with my presentation. And that's how simple it is to build these things. I know we're running out of time, but don't worry, I'm almost finished, because one more thing that I wanted to show you is that having agents is one thing, but agents are probabilistic. They are not deterministic. But when it comes to deploying processes in organizations, you often have to be compliant with the policies. You have to meet some regulatory requirements. And in order to combine the probabilistic world with determinism, we have also created our visual no-code editor that allows to build processes in a more deterministic way, just like step-by-step instructions. Think Canvas for AI or Microsoft Copilot, just much more intuitive. And we can easily shape the processes here, combining them with our agents and with different modalities, and then simply start, for instance, things such as product information for salespeople who can learn about the products and they take a quiz, for instance, or maybe we can have like a speech assistant, sales assistant that we can launch and simply talk to it. Like, I hope you also hear the voice. Hi.
Hallo, ich bin Eric, Ihr Fortinet-Vertriebsmitarbeiter. Ich freue mich darauf, Ihnen heute zu helfen. Hallo Uwe, es freut mich, Sie kennenzulernen. Gibt es etwas Bestimmtes, womit ich Ihnen heute
maybe you
helfen
haven't
kann?
heard me, but speak English.
No problem at all.
All right,
Sorry
good.
about that.
So don't introduce yourself. I just want to know about NAC, because I'm at a meeting with a customer and they are asking me if NAC is secure.
Hallo Uwe, kein Problem, dass Sie Englisch sprechen. Gerne helfe ich Ihnen mit Informationen zu
Okay,
NAC.
it goes back unfortunately to German, but basically, it's just another modality that we can use inside these processes to easily get the data. And what is best here, it's that I told you that there are over 1.5 million models out there, and it's very difficult to choose the right one. What we do is we let you describe what you are looking for. So for instance, you can grab a piece of video capturing part, and then simply describe what kind of information you would like to extract from that video. And based on this, we are able to select the right task. Is it vision question answering? Is it document question answering type of task, etc.? And based on this, simply select the right model for the inference, run it, and get the data for you into the right system. So this is what we do basically. This is how these systems can be built. Of course, we are working with industrial companies, with manufacturers. So what they do is they build things such as automated PDF filler, where they upload a template of a PDF form, and instead of wasting 20 minutes of time, because this is what happens with field technicians during on-site visits. One of our customers wasted like 20 minutes per visit to fill out a very long PDF form. So with our solution, they can simply shoot a video, talk to it, and the PDF is filled out automatically. Or product onboarding, or this business card scanner, voice assistants, knowledge retentions. This is a great example where we help retiring people to where our agents interview the retiring employees to make sure that the knowledge remains within the company. I really love this. This is something that we are currently working on with one of the customers. So that's like we build a knowledge graph through the agents, through the interaction, through the simple talk to the system approach. And we build it to make sure that people can then ask the questions even when the person is gone from the company. And what we are currently doing, and what is on our roadmap, is making this whole thing even simpler to make sure that absolutely anybody can build the solutions without even configuring our system. So we are talking about a meta agent on top of everything that we currently have, that will be able to understand your problem. So you will describe your problem and the agent will configure Blinken automatically. So for this use case of automatic PDF filler, we could simply say, hey, our field technicians waste their time on filling out long PDF forms. And instead of configuring the system, we'll be able to simply ask, hey, this is the problem, Blinken, how do we solve it?
Let me think. We can automatically analyze a PDF form and identify the data to be gathered. Technicians, instead of manual entry, could simply record a quick video on site and describe the details. Blinken VLM will fully comprehend it. Next, our agent reasoning will process it and accurately fill out the PDFs. In the last step, it will deliver the completed forms to an ERP system or simply send them via email to the specified address. Let me build this for you. Done. The app is now live on our hub, ready to use or fine-tune as needed.
That's the future, to describe the problem and get the ready-to-use solution within a few minutes. Thank you very much.
Thank you very much for this impressive presentation. Questions are open, so please go ahead if you have questions, comments. So if you have comments, please go ahead with Marcos. If I see that there is a raised hand, so please go through the chat. In between, I will ask some questions also from my side, because so I know very well the company, but some use cases are new for me, so that's very impressive. One of the things like regarding more and more complex tasks and problem solving, how we will deal with that in the future from your perspective?
Absolutely. So I would definitely say that we are exploring different ways to deal with the agents. It's like, I would say that it is similar to what you do when you run a company. You manage the teams, you put them into the right groups, you set the tasks for them, and the way you form the team and the tasks for them will yield better or worse results. So we are exploring right now different orchestration patterns from ranging from agents that can vote to agents that are supervised to multi-level hierarchical teams as well. And we are trying to figure out how to deal with more complex problems. And the other thing that we do is, as I said, putting these things into deterministic workflows, so they can be like decomposed into simpler steps. This is one thing. And the other thing that I believe is on the radar of everybody right now is the ability to use agents for integration with whatever is possible. So now we have a protocol called MCP, Model Context Protocol, invented by Anthropic, which people claim is like a USB for agents to be able to provide integrations with whatever system exists. So there's already like over 1,000 integrations available for free on the market using this protocol. So I believe that it will only the magnitude will grow rapidly. So I believe that agents will be able to interact with the systems, offload the tasks that agents are not suited for to the deterministic parts of the systems or services, and then simply orchestrate very interesting processes.
That's related to the question in the chat. So Alex also is asking about how do customers react when agents are using Blinken?
Yeah. So
yeah. Do they find this cool or concerning?
Yeah. So if agent has to ask and does it know, it depends on how you structure the agent. So the agent that asked me, for instance, in the demo that I had, asked me because I asked it to first ask if they're about these things. So this writer, they were like asking questions because this is how I configured them. We can go with fully automated agents. However, I'm not a big fan of autonomous agents, to be honest. And let me explain you why. Because I believe that agents and AI should empower people, not exclude them from the process. And this is what we see. As long as the person remains in the process, the results are much better, much better. So there are basically two approaches for this. One very common is called human in the loop, where you define the process. You define the agents that interact or perform some kind of process. They go through a set of steps. And at some point, the process owner or the process designer decides that here we need to have some feedback from the user. So they put the human in the loop to be able to participate at some point. I don't like this approach because I believe that AI should be in the loop, not the other way. And this is what we do. We let AI, basically what we do underneath, it's we construct dynamic graphs after every single turn from the person. So it's like these agents' behaviors are dynamically configured or programmed in real time to be able to support the user at any possible step. And it gives us much more power because you're not excluded at any point. You can change the whatever you have in the process by simply saying, hey agents, this is not what I'm talking about. Reprogram yourself, do something else. So this is I hope this answers. And how do customers react? Well, they love us. Bosch said, for instance, that there is nothing like this in their entire ecosystem. Bosch, the very famous organization. How can we certify that?
All right, so maybe you can type your answer in the chat to move forward with the presentation with Ophelia, but I think that she will also give us insights on building on what you present in terms of humanities, human, and all the social science, how it's interact also with those AI systems from different perspective, especially ethics also that are very important. So Ophelia DeRoy, so please, you have the floor. Ophelia is professor at LMU Munich and director of Munich Interactive Intelligence Initiative. She integrates philosophy with cognitive science and technology, focusing on ethical AI and innovation. So please go ahead, the floor is yours.
Unmute first. Okay, you can see my slides, right?
Yes, perfectly.
And you can hear me. Okay, great. So yes, so actually I will, the transition is almost ideal because I will pick up where the question was heading. That is what happens when we are thinking about putting AI agents with humans, and especially multi-agents with a diversity of humans. So as a kind of background, so I bridge, as just said, background from philosophy and ethics with a grounding in social cognitive neuroscience. So we're also thinking about how humans interact with each other and trying to figure out the differences when we put AI in the loop, as was just mentioned by Bartosz. So let's start with a very concrete example, assuming you're a driver and you're driving the car, which is circled now on the right side of the screen. And as you're heading, you can already see that there is this other car, the green one on the right side, which is waiting to cross the street. So now the question is, assuming that you're going at a reasonable speed, what do you think you will do? Will you slow down, or will you think, well, to hell, I will continue and other people can wait? Well, it turns out that this is actually a classic case where we study interactions between humans, and what happens that the majority of people, depending on the setting, but about 2/3 of people actually show cooperation with another human, thinking that this green car driver would be otherwise stuck, so they slow down. But now the question that we can start asking is what happens with this time you're driving, but instead of just a human driver, you can recognize this green car as being an autonomous car. What will happen? Will the same norms of cooperation apply and people will slow down? Or will we see a shift to more selfish behaviors where you think, well, a human cannot really wait, or it's not polite to let them wait. But in the case of AI, that's fine. And as I said, what we have in cases of everyday coordination, and there are very good reasons for that, we have evolved as a social species. Our brains are socially wired, as it's said in neuroscience. And we, on top of that, have implemented many norms of social cooperation at every level, from kindergarten education to social norms to policy and ethical frameworks. Now, when we test this type of scenarios in the lab and we embed them in various kind of contexts, what we see is indeed that people do not show the same level of cooperation with AI system. Only 1/3, so that is, you divide cooperation by 2. Again, it's not a black and white picture. Sometimes the hype says, we will be terrible with AI and we will beat them up if we meet a robot in the station, or, we will just be hand in hand cooperating. The reality is actually much more graded, and it varies depending on scenarios. And I will say a bit more about that. But what I want first to say is that what we are trying to do as part of the cognitive science and ethics work done in the Emerge project funded by EIC is to actually scale this up. I've presented you just one problem when there is one driver and one autonomously driven car. But what happens when you have a set of multi-agents and many humans? And here really the problems changes not just in scale, but probably in kind, because you have emergent patterns of interactions. We also not used maybe to interact with a set of agents which basically have themselves social capabilities that do not look like social capabilities of humans. What I like to compare this to is that it's a bit as if interacting with agents which have telepathy. You can think that in the case study, for instance, that Bartos presented, the AI agents, they look like, your usual teammates, but the information they share can be done at, instant speed. Any human, in order to share information, will need to actually go and process and communicate with language. So we have suddenly a set of agents who are basically collectively telepathic. And this really changed the norm of social interactions. And we haven't evolved to interact collectively with this type of agents. What is interesting, and where we bring back the cognitive perspective, is that actually what we need to do, and it's really crucial, is to measure the type of differences that are introduced when we introduce different type of agents. With it, be it a singular agent or just a set of 3 agents that, as we just seen, or maybe a large network. What we've been using to test the driving scenarios is actually a tool from experimental economics. You may have heard from a series of recent Nobel Prizes, but it was actually started by John von Neumann, and things like prisoner's dilemma, where you have basically to trade off certain of your preferences in order to negotiate with another agent. And we have, what is great, is a wealth of data from human-human interactions that we can compare now with human-AI interaction. Here we could replicate and vary in a formal way. Also, following Sadek, we have a way of thinking about the optimal interactions in these cases. And we could see actually that consistently humans actually cooperate less with artificial agents. Interestingly, from the ethics perspective, this comes also with the expectation that actually the AI will be cooperative and benevolent. So the EU Act has stressed that AI is meant to be benevolent. And it's a bit like thinking again back to the driving scenario, that you know that this green AI car will not try to force their way in, which a human driver may. And so here, because you expect the AI to always do the right thing, you can actually find an opportunity to exploit its expected cooperation and behave in a more selfish way. What I'm trying to see here is that in the balance between humans and this trade-off between being cooperative and being selfish, which is based on reciprocity, we introduce a new type of agents which are behaving very differently, including in this kind of by design benevolence. You will never meet a by design benevolent human. Everybody is capable of being more or less benevolent depending on the context and the situation they're in. What I show may look very formal if you have other use cases. Just asking people to enter response regarding their cooperation may be detached from reality. More and more what we are doing is to embed these future interactive scenarios into virtual reality. For instance, we can measure not just what people report, but also how they move. For instance, how pedestrians will actually decide to cross the street if there is either a human driver or an AI driver. And here we can measure the fact that actually humans tend to gently sort of throw themselves much more in front of an AI car, again, expecting it to slow down, that they are doing when a human is at stake. So by introducing these agents in a rich social context, we're actually changing the rules of the game. Now, the social coordination between humans and AI, we had the articles that we published was picked up by the New York Times, and you can see how science journalists like summarized the finding that AI should be afraid of us. But basically what we tend to see is that statistically we're much less likely to be cooperative, to reciprocate the politeness and the benevolence, and to uphold social norms. Now, society holds because of all these patterns, which are, again, statistical. Now, let me give you a set of more sort of applied case study. When you have a comparison, we hear about this between an interaction between two colleagues in a company, or now a worker and an AI assistant. Now, there is what I will say, we know a lot about common sense, but there is social common sense in terms of turn taking. For instance, when do you ask questions? When do you interrupt? And when do you check that you share common ground? Now, I'm not saying that you cannot achieve the task at the end, but the rules through which you will achieve them will be very different if you introduce, for instance, an AI for good or for worse regarding this social common sense. A second thing which is closer to the service industry in this case is that you can imagine what happens when you have an automated consumer service platform. And you can imagine that on the left side, what you have is the client, and the client has the choice between two things when they call, let's say, because their electric appliances is not working. They can actually do the good thing, they describe the problem honestly, or they can do the bad thing and hide part of the issue, that they did something wrong first. So there is this sort of cooperative, honest choice versus the less honest choice. Now, on the respondent side, you have the possibility also to be a good service provider and investigate the issue thoroughly. But you can also have the possibility, to do something much more rushed and actually not investigate the issue as well. Now, the prediction here is that when a client speaks to a human, we're much more likely statistically to find ourselves in the good situation, where the client is more honest, warmer, more cooperative, and the human does the same. Now, in the case of an AI, this is also the case of a good investigation by principle, but because of that, actually the client is much more likely to want to actually misdescribe the problem and hide the issue. And if the AI starts to learn from the behavior of the client that this is the case, then the risk is that we find ourselves at the other end of a cooperative interaction. So the risk is this glide also, not only from a shift in the human perspective, but from the learning of the agent. Okay, so from here and what I call the social common sense, the insights from cognitive neuroscience and ethics are threefold, if you want to summarize at this stage. On the one hand, we talked about this highly interactive system, and what we need to figure out as a key thing is not just that the humans will have expectations regarding the other colleagues, but they will transfer these expectations that they have with humans to the AI. And then you will sort of predict the behavior and try to predict how other people predict you, and so on and so forth. So we have several levels of reasoning here. Now, the second point I try to highlight is that regularly we sort of expect these interactions to turn out in a cooperative way. We're not just hardwired to read people's mind, but we've also sort of learned to follow by default rules of politeness, let the car pass, let the bikes first and the pedestrians, for instance. And this is also driven by rules of politeness and reciprocity, which means that we are not just driven to maximize our own individual values as humans. And as I said, what happens is tricky, because once you introduce benevolent agent by design, then there is a risk of exploitation of this benevolence by humans. Now, I know that I'm generally trying not to be the ethicist that only puts the risks, and I want to show the opportunities, but let me start first by the risks. The risk here is an erosion of social norm, and you can go on the internet and read several articles talking, for instance, about the fact that using Alexa, if you give Alexa and this automated AI agents to children, then children don't learn to be polite because they can just shout orders at these machines, and then they don't learn to be polite with other humans. So there is a risk that humans who learn to be rude with AI may actually transfer these attitudes to other humans. On the other hand, if an AI is used to human behavior which is non-cooperative, you can imagine a smart driving car that learns that humans never let them through, then they will have to learn another way and maybe start to be more aggressive or honk, or I don't know, in order to meet his goal, which is cross traffic at some point. As I said, we may go from the perspective where autonomous car is being presented as a promise to improve traffic to a case where actually only a few human drivers behaving in a very selfish way could ruin that promise. Now, opportunities, I have to flag this. When we have conducted various versions of our experiments on cooperation between humans and AI in other countries, we find actually that there are other social norms which are much more generous towards the AI, and notably in Japan. The Japanese participants proved to be as cooperative with AI as they are with humans, and we are trying to think about both the social norms and the cognitive differences that can explain this. And so there may be other differences to be expected depending on European, also cross-cultural differences, but also generations when it comes to interacting with robots. The way forward, and here I'm talking more about opportunities, is that we have really to bear and trade the benefits. There are many research papers. Hedi was mentioning the link from fundamental research to innovation that actually have demonstrated from very theoretical abstract context to real case studies that adding AI contributors can actually improve performance, be it creativity and accuracy, and even sometimes cooperation. But here there is a qualification. This all works if the participants, at least in the lab, don't know they're interacting with an AI. That is, the AI is presented at best as an ambiguous way, as maybe a human, or hidden and presented as a human, which is a big problem for transparency. The moment you say, here is a bot, then we see an erosion of social norms and cooperation. So how do we solve this? Our solution at the portfolio EIC level, but also in Emerge, has been to try and build social and context awareness in AI system and try to improve this situation through the development of some form of minimal awareness. But I think we have also to rethink certain principles of our ethics, like this presentation of AI agents as always benevolent, for instance, may actually backfire. And also think about the changes to social norms in hybrid societies and context. Now, I want to end on an opportunity here, I think, for private-public partnerships and a new opportunity also for civic and client participation, is that at the moment, what we are in a situation where we do social simulation, for instance, about the scenarios with AI autonomous driving cars. We do them in the lab, we do them in partnership within European projects with specific startups. There is a science of measuring the social interaction, and it's not widely available. And so to leave you with an opportunity here, I think that's, there are spaces where you could think that actually, I've flagged here the Team Lab, which is this Japanese AI artist studio, which started in early 2000 and now has making, I think, like more than 60 million in revenues and welcomes millions of visitors in their spaces, where here people could not just see and contemplate the new technology, but be part of wide-scale social simulations where people can test futuristic scenarios with diverse people, in an inclusive way, and really testing what I would like to think are socially augmented interactions. So we could have a sort of equivalent of, let's say, an interactive space or museum for digital experimentation here. On this, I want to thank you for your attention, and I'm happy to take questions.
Thank you, Ophelia. That's great that you mentioned this example of Kate and Alexa, because I have a 2 years old boy. First word he said is papa, and the second one is Alexa. So that's crazy how this new generation, this kids, how they will deal with AI. That's a big question. And I think in the Q&A channel there is questions also about this. Maybe I'll let you go through, Ophelia, and feel free to answer the questions. So maybe
yes.
the third one and the fourth one, yeah.
Okay. Do I think we should give Alexa AI a face that reacts to commands and looks sad if it's ordered and happy if you say please? So children living we just mentioned. So I think, I mean, here I will be brief. It's a very complex issue. Already the question is, what is the right age for children to interact with technology and screens, and I think here there are critical developmental periods for the brain, and we should not interfere with evolution here too much, and think that you should first learn to interact with humans and less with AI agents. So I wouldn't recommend what I will say for very young kids. Now, older kids, you can actually maybe have a sort of as if version of AI agents having emotions, in the same way in which toys are embedded with fictional emotions, or in video games they're used to fictional characters. I think we need to be very careful regarding the assumptions that AI really have genuine emotions, because so far all the cards are still on the table, and this is really not a trivial attribution to make. So if it's introduced as if and a fictional character, yes, it could actually promote more cooperation. Conflict from I see that there's a strong view that should always be told when you're interacting with an AI agent. I absolutely agree. Now, I'm referring here to a series of paper, for instance, by the lab of Nicola Christakis, showing a lot of experiments have shown that you can introduce AI agents and help people to solve cooperation and coordination games better. But usually in the lab, you can do it because you're not subject to the same ethical regulations, and you can compare what happens when you announce to people that this is an AI and when you don't. And what you see that when you don't, then indeed these AI agents, they learn very quickly how to maximize the value. And if you ask them to maximize cooperation in a group, they do it very well. But the moment humans know it's an AI, then you have these multiple levels of expectations, and then you mess up with the system in such a way that it doesn't work that well. So at the moment, we still don't have a solution. Basically, it's not an engineering problem because it's a social problem until we can do social engineering, which I don't recommend per se, but because we can't do that, then we have to bring in, and I think this is a great thing about the EIC, to consider like bringing not just computer scientists, software developments, but also expertise from the social sciences and the humanities to actually deal with the social aspect.
That's great. So, unfortunately, our next speaker had some network problems, so he's disconnected. So maybe we'll move directly to the panel, and then if he can later, so he can join us. I'm happy also to have two more speakers in the panel, Hedi Karray, who is an associate professor of neurosymbolic AI at Birmingham City University. She is leading the NLP lab and research innovation in the College of Computing. Also, Thibaut Jeangen, he's a leader in technology, engineering, and business with over 25 years of experience in manufacturing industry. He's also he has been the CEO of Sapka Group, and also he founded Common Sense Robotics company. He's also one of the directors of ADRA Association. So hello Thibaut, hello Hedi. Maybe we'll start with you, both of you, to get first feedback about what you already learned from the presentations we got today.
Should I go first?
Go Hi, everyone. It was quite matching with what I am working on, especially the first presentation. So from the introduction that Hedi made, I'm an associate professor of neurosymbolic AI, and it's been some 20 years that we are trying to make an emphasis on this area, the knowledge graph aspect, the neurosymbolic AI and all that. And seeing in the first presentation, the cognitive AI, where we are trying to combine the data-driven neural network models with the symbolic embedding, it's quite a sign that we are getting there, given the advantages that these technologies have. Even now that we have reached so far with the large language models and with all these excellent AI tools, still we see that we have challenges with interpretability, with hallucinations, with explainability, and so on. And hopefully also the direction that we are getting by hearing more in the third presentation about the social aspect and the societal and ethical and responsible AI aspect embedded through these symbolic rules will make the future brighter. Thank you.
Hello, can you hear me correctly?
Yes, perfectly, Thibaut.
Hello, everyone. I'm very happy to be part of this panel discussion, and thanks a lot for the invitation. Just a couple of additional words from what Hedi said. We are basically trying to improve productivity in manufacturing by automating manual work in the manufacturing industry, using the convergence between AI and robotics. And of course, you know, manual work is at the heart of manufacturing. It comes from the word Latin, manufacturing, made by hand. And well, automating manual work has been on the program since many centuries, actually. It started from the industrial times. But what remains now as manual work is the most difficult part to automate, because basically it has a number of characteristics, like you need to touch the product, so you need to have force and motion control. But at the same time, you also need to replan every time, because you don't know in advance, for instance, if you screw something, if you rub something, how many times you need to do it. So basically you need to continuously monitor what you do and to replan your actions. At the same time, you need to understand the intention of the task, because it is not like hard automation where you can pre-program everything. You need to basically understand what is the intent behind the task, what is the intention. And clearly today, the, let's say, robot foundation models, the end-to-end correlations that we see really on the media and that are mind-blowing, of course, well, basically they lack the guarantees. They lack the reliability that you need in industry, because they could hallucinate. So you of course, if a robot hallucinates, it can be dangerous for the product, for the robot, or for the people. But at the same time, you cannot have the same reliability in terms of guarantees, meaning also that when those robots are trained by imitation learning, by mimicking, basically the robots do not understand the task. It's actually the understanding of the intention of the task remains in the head of the trainer. It is not in the robot, or it's not on the data. It's not in the foundation model. The intention, the understanding of what is, let's say, the intent behind the task to achieve, for instance, a certain assembly, things like this. And that's why all the, let's say, methods, the new architectures like neurosymbolic, like hybrid AI, are so important, because they allow actually to have the cognitive part, to have the understanding of what is actually the aim of the task there, which also means that in terms of the number of data you need to be able to create, let's say, the understanding, it's much less data, because you don't need to have all the data, and you can also avoid the long tail effect. So basically, just to answer your question, Hedi, I found it very, very exciting to see that, you know, the trend is coming. There is more and more openness. There is more and more, you know, you're not shy anymore to talk about this. It's not like everything should be gen. No, actually, now we start to realize the importance in terms of data, reliability, computational power of those new architecture. And that's where also I think there are huge opportunities to develop alternative methods that are maybe not currently mainstream, but that have a real potential of having real life applications in manufacturing, for instance, which is again a very important part of, you know, the value creation in society. So that's why
that's great to talk about the value creation in terms of society, but also in terms of business. And I see that Eduardo Casado, who is like one of our speakers now, is connected. So maybe Eduardo, we can go through the questions, and like you can have some comments about the business perspective regarding this cognitive AI and this new generation of AI systems from like you as an investor. I didn't mention, but Eduardo is investing in technologies, and he started with Boursorama. I think that, you know, Boursorama Bank, and it was his company.
Yes, that's right.
So from the business perspective, how you see this, I mean, the investment in terms of the added value that we can have from next generation of AI systems that have cognitive capabilities?
I think we should have into account two different areas of investment. One related to the AI as building AI capabilities, and the other one as everything we can add to other different industries. So there are a lot of industries, especially healthcare industries, that are going to take advantage, a huge advantage of this AI investment. And the new cognitive architectures that we are going to develop. I think those are the big paradigm that we are going to have. As you know as well, I'm investor in one of these general AI companies that instead of going through the generative AI, go through a different architecture. That's what I think.
And then like that's why also I'm asking this question is like, I mean, usually when we talk about investment in AI innovation in Europe, private investors like, you know, there is some skepticism in things that are not on the hype. So that seeing you investing in a company that is not following the hype and taking another kind of AI systems, that's like raise the awareness about the vision for the future regarding such kind of systems. But also, you mentioned something interesting, and I would like also to back to Ophelia on that regarding this artificial general intelligence, the hype of this kind of, okay, I don't know if it's reality or like just imagination. How you perceive this from social and humanities perspective?
I think there's this image I have about generative intelligence, artificial intelligence, which is like a pile of bricks. You have another brick, you have another brick, you have another brick. It's like having another data center, data center. When we are talking about AGI, is a change in the architecture. Is like having the Eiffel Tower. It's completely different. That's the reason is completely changed in the cognitive architecture of the AI.
Mm-hmm. Okay, so let me hear from Ophelia from like her perspective regarding this AGI, because there is a lot of speculation today, you know, that's like, okay, those big tech doing LLM, they say, yeah, AGI is by the end of this year or next year we'll have AGI. So, I mean, till now I didn't find a quite well definition about this already in the literature. And I mean, what is your perspective?
Yeah, I think that's the AI is as just mentioned by Eduardo. I think as introduced a qualitative change. AGI, on the other hand, you can think about it. That's why quite often in the debate it's linked with consciousness, because the idea is to say that you have various sets of modules, and then you need an integration and several levels of reflection on how the integration is being performed, so that you're basically reproducing in an artificial system what the human brain is capable of. So we don't just have cognition, we have metacognition, which is we know how well we are doing. When I solve a math problem, I have a sense that yes, this is the correct solution or not. But I also have a metacognition, which is to say, should I focus on this math problem or should I focus on another problem? And then I have another metacognition, which is expecting what other people expect of me, and so on and so forth. The only thing you can think about, in my sense, for general intelligence is, a system that has not only this capacity to integrate modules, but has this several levels of reflexivity, so that it always balances different tasks. So it doesn't just do manufacturing, it also knows when to go and do the coffee and when to stop and play with your son to entertain them. For me, that's as you were saying, Eddie, that's a very speculative scenario. I think there are vested interest from some research sides here. The question is not how far is the future is it? Is it a desirable future? Right? Is it the future that we want? And especially when you think in terms of energy consumption and ethical and social risk and reliability as well. So I think we should dissociate the two questions. Can we do it? And should we do it, or do we want it?
That's a very, very good question, Ophelia. I think do we want to have it? This is the thing, because we have a human brain that is able to think like us, so it's able to make also mistakes like us. And then we're going to have we're going to have one data center, 2 data centers, a supercomputer. It's going to solve a lot of problems, but it's going to create a lot of problems.
That's amazing you're talking about, because Thibaut, from the industrial perspective, using robots, as you said, like, I mean, the risks behind those super intelligent AI system that will be embedded in the physical world. How will deal with that, and what could be the right solutions and directions to try to have safer AI deployment in the physical world?
Yeah, and well, first there is, and I'm not a specialist there, but a big question about, can you achieve AGI without being in the physical world? That's the first, of course, question that you see happening a lot. And then the second question, more for manufacturing, should we go for the humanoid route, where basically we kind of just replicate the current human beings' operations, or shall we actually not try to mimic ourselves, but actually to do something different? So actually basically design products, design processes in such a way that we can achieve things that are not achievable today, because they are not desirable, they are dangerous, they are difficult to do, things like this. So there's already the question about, should we just try to replicate what we can do currently as human beings, or should we actually try to basically do things radically different that only robots or only that kind of artificial intelligence can do? So that's already a big question. Of course, the current world is done for humans, so the first step would be just to automate what is currently done by people. But you know, after this, there's a lot of things open. Now, I'm not too scared about the robots invading us and the robots starting to create their own factory, their own product, because there's still a long way to go, especially, you know, in industries where you don't have any data available. But there is a huge opportunity, just a much more modest improvements, which is design for manufacturing, which is being much more effective, increasing productivity, reducing waste, increasing quality, increasing the variability. So that's already a huge benefit for humanity. So I don't see that as a threat. I see that as a great tool that we should just use in an industrial way, where basically that's where the big difference is going to come. So it's not going to revolutionize the world tomorrow, but it is step by step going to keep improving. And I agree, there is still also the question about sustainability, consumption of data, consumption of power. And that's where, again, the new architectures, which are neurosymbolic, that are much more, you know, cognitive, are going to make a huge difference, because otherwise it's just not, from an industrial perspective, about reliability. It is just, I just don't believe it at all, actually, to be anywhere near, if we don't find new architectures. And again, what is currently being discussed about the mix between cognitive is going to be very important.
I would like also to hear from Bartosz about that. So you are developing such kind of AI systems. So how do you see the future? You already mentioned regarding making the human in the loop and so on. But what about new architectures, new vision regarding this? And I mean, your vision about AGI, let's say, I don't like this term. I call it human-like intelligence, or like near intelligence, or like mimic the human intelligence. What is the next steps in Blinken as a startup to go forward on that kind of technologies?
Yeah, so thank you. First of all, I would like to say that, of course, you mentioned that there is no single definition of AGI, and I absolutely agree. People understand this differently. And to be honest, I'm not even sure if the progress that we are currently experiencing is something that leads us towards the AGI, as some people understand this term. Because does it mean, should we focus only on reasoning or also on consciousness or other things, the will to survive, the instincts, and everything that is part of us as human beings? but not necessarily part of the evolution that is happening right now in the AI world. So I don't think that will to power, desire for control, power hunger, competitive drive, all these things are part of are they part of AGI or not? Should they be or not? Will the AI be able to compete with us? I'm not talking about fight, but about being better than us without these things, without desires, without the needs that we as humans have. I don't know, to be honest. But so it's, in my opinion, without any scientific background, of course, and some papers behind it. Just my way of thinking about it is I believe that the evolution of AI currently makes it a better tool that will, but still just a tool that will process data faster and help us to reach out to the appropriate knowledge faster. Andrew Karpathy once said that LLMs are basically compressed knowledge about the world gained from the data it's being trained on. So basically, the LLMs learn the distribution of the language, but also of the knowledge that exists out there. And I somehow prefer to perceive AI and generative AI this way, rather than something that will be dangerous for us or will put us on the same level as because even now AI is much better than we in certain tasks, and certain can perform better than we do. So I think it's like a orthogonal dimension to what we are talking about. It's not necessarily going through a linear evolution towards being humans, rather something going in a different dimension. So that's my point of view on AGI. And you also asked a question about the future of architectures. So I really believe that from what we are doing right now, that multimodality still has a big area to evolve. Basically learning and having models with different modalities as it happens often now, and trying to do the projection between them is very limiting. So for instance, if we have models that's been trained like vision encoders, and then we have models that represent the language, and there's the projection layer between them, the problem is then the distribution of the language, spoken language, influences the result. So if we, for instance, ask a question about an image, we can get an answer that is based on like how many people are there. We can get better answers based on the distribution of the text data that it's been trained on, not solely the vision capabilities. So nowadays we start having models that are trained with different modalities simultaneously, and it opens up new possibilities, and I believe that it will all become more natural for us humans to interact with such models, being able to shoot the video, talk to this model, being able to interact through the emotions, through non-verbal communication as well. This is something that will happen sooner than later, I believe, and will become this.
That's a great bridge to ask Elira as an expert in natural language processing regarding how we are moving, how this language evolution to other kind of expression like will improve this interaction between humans and AI systems.
Yeah. If I carry on with the point that was made about the AGI, what I have noticed in literature is that there is a tendency to follow a middle layer. So like not having the full AGI, but having these agents as thinkers, or not even having them as models that will just solve a small task for us. So we use them as tools, but we use them in collaboration with us to help us in our thinking, in our reasoning, in innovating. I've also noticed another tendency for AGI per domain, which I find it quite interesting. Very recently, for example, I have been engaging with an initiative to have AGI for the built environment, which if we put it in technical terms, it will be similar to having multi-agents who are solving different problems of the built environment. But here we see also other questions being raised. Even for humans, do we have a human who has expertise in all the domains and subdomains? So even if we take just built environment, there are so many fragments inside it. And if we talk about the NLP part, many challenges within the NLP space as well. Yes, there are brilliant application of question answering and all the chatbots that we have in there. But what is lacking currently, and what different groups are working towards, is how do we have the context in getting the right answer? So how do we embed the context? And yes, there are some solutions to that, including the technologies that were mentioned. But furthermore, how do we embed the culture bit? Culture plays a crucial role in the way we interact and how we expect these machines back to interact with us. There has been a very recent experiment with a certain diseases where 50 doctors were asked, and then there was a hybrid set up where were agents and doctors being asked by diagnosis and the AI being asked. And the AI performed better than the doctors. But where I want to focus is that the human and machine part which was expected to be the greatest, was not there. And this is just because of the gap that we have in terms of communication, and also the point that was made earlier about the intention, being able to give or to give a clear intention to what we are asking from the agents and from the machines.
Mm-hmm. So, I mean, that's important regarding what you are saying regarding the multi-agent system, and my question is for Sadek regarding the challenges that, you know, multi-agent system is an old topic in AI, and now it's the hype, you know, and for sure that there is a gap between reality in terms of what are the challenges from scientific point of view and what we are seeing today. So what are your comments, your thoughts regarding how to bridge the gap, how this area will improve in the future? What are the next challenges on the topic?
Yeah, that's great. Thanks for the discussions. It's very interesting. I mean, related to the question you asked, Hedi, about multi-agent systems and where we are going, what are the challenges? I think the challenge that we are facing now is to have a proper characterizations of the concepts we have discussed so far in a quantitative way. I mean, think about, we want to build a system that has a certain capability. First, we need to be able to express that capability in some space. I mean, think about awareness, consciousness. I mean, give me a formal definition. We don't have a formal definition yet. The advances we saw with LLM, what happened was that we had a scalability with respect to the size of the model. We had a scalability with respect to data, and we managed to find the right architecture. So we had these three elements coming together to make a step change in how things are evolving. The same thing happens when you want to develop the next generation of multi-agent systems with new capabilities. You need to be able to formalize these concepts somehow and find the right architecture that can capture those concepts as part of the processing. I think this is the main challenge that we are facing. But the good news is that we are accelerating building these systems. The reason is because of these large language models. So far, we didn't have any way of testing cognitive capabilities. With these LLMs, now we can test it. I mean, I can somehow, as a black box model, I can compare one LLM with another one and say, this is perhaps a bit more intelligent than the other one. It's providing better answers to me than the other one. So this capability to test new technology enabled by the current generation of LLMs will accelerate things quite substantially. I don't want to suggest any timeline, but I'm expecting to see lots of changes in how we design cognitive multi-agent systems.
Mm-hmm. Great. So when we talk about multi-agent system, usually we talk about also master agent and slaves agent. So Ophelia, this master and slave, and this interaction between human and AI agent, how will be like, could be our interaction? I mean, people talk about singularity and it's like, okay, maybe AI agent will be the master and humans will be the slave. Or now our interaction with AI is like we are the master, they are the slaves. So how it will be, how should be this interaction?
So I think that here we need, personally, I think we need to divert the attention from this like confrontation. As we're used by both the popular culture and, you know, the Terminator coming and other like interacting with nice robots, to have this face-to-face between us, you know, individuals and the AI, to really introduce the right actors, you know, who programs the AI, who owns the AI, what are the companies and the interest behind it. And I really don't need to allude to any political situation to show and demonstrate to everybody that that I think we should really think as everyone, you know, researchers, investors, funding agency, business owners, not just about those, you know, we live in society, but they're political as well. And therefore, we need to care about how the powers are distributed. And it's not the AI who have the powers, the people who own them and program them. So if they're masters and slaves, they will not be between us and the AI, but the question of regulation of companies and data flows and open data. And this is really the conversation about power that we need to have.
Mm-hmm. Great. Another aspect, yeah, I see that Bartosz rising hand. Please go ahead. After that, I have a question to Thibault.
Yeah, I just wanted to add that we have, you know, that there are multiple agent collaboration patterns. So it's not only hierarchical. It's not that it's always master and slave. There are distributed, centralized, hierarchical, and also, you know, sometimes agents. There are three often used terms like cooperation, competition, and co-opetition, which is a blend of cooperation and competition, where agents collaborate on shared tasks while competing on others. So there are different patterns, different strategies, and no single one that fits all. So it's an area of exploration for researchers, for companies. I believe that's what I mentioned earlier, that I believe that this is a space where we will have some great findings in the upcoming months.
Great. So while Eduardo is here, before that, I have problems with the network. I will ask him the question before you, Thibault. Sorry for that. So I would like to have some focus on AI investment as an investor. You know, in EIC we are funding startups, we are supporting innovation, and sometimes, I mean, the spirit of EIC is to put public funding for risky and innovative approaches. From the private perspective, how you deal with that, as like from your background, you have experience in investing in China and you back to Europe and so on. What is the perspective of an investor to make a decision? I believe in this company, I put millions on it. You are muted, Eduardo.
Hello, now?
Yes, now it's okay.
I think right now the role of Europe is putting some investment, a lot of investment in fundamental research. Right now, VCs in Europe, they are not willing to take so much risk as VCs or investors in the US. We are seeing that investments in Europe, they want to have some kind of return already. They want to see some operations going on. They want to see some results. And they are very afraid of investment in companies that tell them we need 1 or 2 years of additional research to come out with good architecture or with AI products.
Great. So now for Thibaut. So you come also from a business background. You run big company, and you build your vision on real things coming from the real needs from industry. And it was amazing to talk with you about the aspect of the common sense, how to bring this common sense, and why you believe that you are investing on that it will fly.
Well, thanks for the question, which is, of course, a very broad question. But reflecting, and by the way, that's also the reason why we decided to name our company Common Sense Robotics, because there might be a big difference. Because of course, we are all excited by the sheer power and the mind-blowing aspect of Gen AI, LLMs, things like this. But let's not get too excited, and let's not extrapolate too much in a future that probably might not happen as easily. And it's not the first time, that we kind of overestimate new technologies, and we think those technologies are going to change everything tomorrow, whereas actually they change everything on a much longer time scale. And there are many examples of that. Recently, drones, for instance. Drones were a big hype, and we still don't have pizza deliveries by drone anywhere, which is basically the sheer reality of one business. Does it make business sense actually behind expectation? So there needs to be business case, but also just regulation, safety, things like this. So basically, common sense. You could define common sense, and there are many definitions. Like we discussed consciousness, intelligence. These are another of those definitions or those words that carry a lot of things behind them, and that's difficult to define. But I would like to actually propose 4 characteristics, not a definition, but a characteristic, and that common sense is actually the interaction language, the interaction protocol between human beings. It's basically what makes us as human able to interact today, for instance, interact with different cultures, interact with different people, because there are 4 characteristics. The first one is sharing the understanding of the physical world, time and space. And that's why embodiment is so important, because the first characteristic of common sense is understanding time and space. Second characteristic is causality, being able to make causal relationships. It allows us to learn, allows us to plan, allows us to understand. The third characteristic is empathy, is intuition, is kind of, we discussed about multimodality, is basically this, being able to understand, if I do like this means, oh, I'm surprised, everybody understands this. The fourth characteristic is norms, values, social sense, that, we protect ourselves, and unless we are, psychopaths, we try to protect also the other ones. So those 4 characteristics, physical space, physical understanding, world modeling, causality, empathy, social norms are the 4 characteristics that somehow should be there if we want to have intelligent, between quotes, AI. Well, LLMs, okay, empathy, why not? Physical world, embodiment, robot foundation models, why not? But we are still far from causality. And that's why, again, those new architectures with, knowledge, intention, cognition are so exciting, because there might be the aspect of causality, which of course then allows us to talk about safety, about the long tail, about the little data that actually happens once in a million times, but if it happens, it's a catastrophe. And if you've got correlations, basically those little ones tends to be filtered out. And that's why those current classical hype architecture are not safe. Basically are not safe. They are not reliable. So basically having those 4 characteristics of common sense from the point of view we take, which is manufacturing, reliability in manufacturing, is really, really fundamental. And that's somehow the way we come in. and we'll see where it goes. But again, from a business standpoint, we're looking for using this as a tool to increase productivity in actually manufacturing and industrial processes, and a way for Europe to keep or to regain leadership in technology. Because of course, I like the analogy of Eduardo about you build bricks and you put big walls, you got a lot of bricks, but actually we may not chase bricks. Maybe we need to chase the Eiffel Tower. Right? So basically, let's not try to just build bricks. Let's think about something fundamentally different that is going to be a big step forward.
That's great to finish with this words, Thibaut. So before closing, we have an online survey. So I asked Jessica to share the screen, and I also ask you as a speaker to participate also regarding also the vision on what will be the future for AI in terms of capabilities and also in terms of satisfaction for the upcoming webinars. So I'll participate.
Yes,
It will
thanks
take
a lot,
2
Hedi.
minutes. Yes, go ahead.
Yes, thanks a lot, Hedi. So you can see here, there is the QR code or the code that you can type into menti.com. So don't worry that because the code will be visible for all the slides. So this will be done in 2 parts. So in the first part, we would like to gain some from you some information about the content of this webinar. So something about the AI capabilities. So what are the main gaps to develop and adopt those AI capabilities according to your knowledge? Of course, this survey is anonymous, so don't worry if you would like to take just a minute to reply. It's really perfect for us. I think I will be really some seconds more, and then I can go to the next slides, so we can cover all the slides that we have. Okay, thanks a lot. I will go to the next one. What is the most risk impact of such capable AI from your perspectives? Also here, I will stay some seconds to make you read also the answer, and then please feel free to choose your answer. Okay, thanks a lot. I will go to the next one. What is the main opportunity of AI innovation from your perspective? Okay, I think I will go to the next one. Thanks for those who are replying. What is your recommendation for the future of innovation in artificial intelligence? So also here you can see 4 possible answers. Okay, thanks a lot for these replies. I will go quickly to the next one. Sorry for this, but we are really out of time. So we will just some questions about the satisfaction of this webinar that you have attended to. So how satisfied were you with the content presented during the webinar? At the end of this some slides, we will have also an open question. So if you would like to add any comment, I will give you some time to fill also that. Has the webinar helped in increasing your knowledge regarding the topic? Of course, we are also available if you have some questions to reach us via email also after this webinar. And then, are you satisfied with the overall webinar organization? So everything that was before the webinar itself. Thanks a lot. Okay, so finally, would you agree to stay informed about our future activities? So we plan to have some more webinars, as Stefania said at the beginning, and then also some other activities. Thanks a lot for this. And I will give you some seconds also to share any additional comments or feedback you have about the webinar. Of course, as I said, if you wish, you can also reach us via email to send us any comment or question that you may have, also to the panelists and to the speakers and to our organization.
Great, thanks, Jessica, for that.
Yes.
Before concluding, I would like to thank our speakers again. It was a very insightful presentation and discussion, very insightful thoughts. I think it's a preparation for the future. We will continue on that discussion. I invite you and all the attendees to join us for the upcoming event. So it will be during the year, and I will also prepare a roadmap for AI innovation based on what happened in these webinars. And for our speakers, we will be consulted again to build the content together in order to shape the future of responsible AI innovation. So thank you very much again, and see you next webinar. Thank you. Bye-bye.